Hello, my name is CF Kwong. I hold a PhD in the electrical and electronic engineering. From this August onwards, I'm the associate professor of the in electrical and electronic engineering. Can you hear me, right? Very clearly. Okay, good, excellent. So welcome to the Faculty of Science and Engineering. So I'll be the one who actually take the tour for today. I have my colleague over here, Kate. She's from our technical services, so she'll be helping us as well. So Victor, just come in a little bit. So that's our that's our sign, Faculty of Science and Engineering. So we in the Sir Peter Mansfeld's building. So Peter Mansfeld is one of the inventor of the MRI machine who actually won the Nobel Prize. So if you can look over here, our faculty has what they call that has 9 schools and departments. We have architecture and built environment, chemical and environmental engineering, civil engineering, electrical and electronic engineering, materials manufacturing, and mechanical engineering, school of aerospace, computer science, geographical science, and mathematical science. And for that particular part, that we have, this is where our research groups, we have various research groups. So as you know that academics here, the professors here, they are actually the people who are supposed to be very active in research. We have 2 key laboratories, the provincial level key laboratories, which is something that we are really proud of. Things like that. If you can see over here, on the top here is where we receive accreditation from all the relating accreditation body. Like for electrical and electronic engineering, we are accredited by the Institution of Engineering and Technology, which is part of the Engineering Council of the UK, which means that if you graduate from our degree, you can register professionally with the Engineering Council of UK as a professional engineer, right? So okay, I think maybe we go to the first stop, which is something that we've been working for the past 2.5 years, I think maybe 3 years, I lost count. So the first stop is that what we are going is what we call the innovation lab, right? So innovation lab, come in here. I think probably if you look here, this is what innovation lab is. It's not really a teaching lab, but if students got ideas, right? The students got ideas, they want to develop their ideas into a prototype. And hopefully in the future that the prototype can be spin off into a startup company. I think one good example is if you play drone, right? If you play drone, one of the famous company in the world that built drones, the DJI, actually come up from a startup companies from the ideas in the innovation lab. So if we can probably just go in this innovation lab, you can see students' projects. What you can see here is that the students actually built robots in their free time. They build robots in their free time, and they go for competition. Well, it's not really a complete prototype yet, but you know they're progressing quite well. They're ready for competition, and we have this particular part. This particular part is that they are building an automated machine to create a printed circuit board. You know, the circuit board inside your electronics product. So the students are trying to build that one by their own. Right? Interesting. And if you can see over here, this is where we built our electric car. Racing electric car. So this is where we built the car to join the competition. This is what we call a Formula Student competition. So this one is almost 100% is built here locally inside on campus by the students themselves. So they also do the braking system, the hydraulic systems, the electricity to power the motor itself. right? And then before they go for the competition, they need to practice, all right? They need to practice like a Formula One driver. So they go through this part to do their simulation for their practice. So yeah, that's all about. I mean, if you're here, you got ideas. So what we do is that we will give you some money to do some of your to explore your ideas on this one. Okay. So okay, excellent. Maybe if we go to the next lab. The next lab will be a research lab. The research, remember I mentioned about Sir Peter Mansfield, the name of this building. And Peter Mansfield, what he do is that he invented a new technique for the MRI, the one that scan yourself in the hospital, where you can see inside your body without, it's a non-invasive method to look inside your body. And the interesting part is that Sir Peter Mansfield, because of his research, he won a Nobel Prize for this one. And this is our this is why our MRI research lab is one of the strongest here in the world actually. So you can actually look at the MRI lab. We can come in, come. So these are the MRI labs. So we have the research assistants here and PhD students working on their MRI work. Not so sure we can see. Can you see inside there, the MRI machine? Yeah, can you just open the door? So what they do is that they just see from outside. They won't go inside, right? So you can see the MRI machine. Thank you so much. Don't go inside, don't go inside, don't go inside. All right? You can see the MRI machine. It's the same thing that you see in the hospital. Okay? Okay, excellent. Okay, cool. Next lab. Cool. All right. Okay, just nice. We have students in this lab. This is a machine lab, right? So what the machine labs actually do, they actually do a lot of, they create a lot of parts, gears, things like this in this lab. Just nice. Our students are doing it. Hello. Hi. Okay. So, yeah, students, continue working. So, these are mechanical engineering students, right? So, probably don't go too near because they are trained as it. So, you can see even a lady actually, even a lady actually do a cutting themselves. Okay, wait, just a second. Yeah. No, it's okay, it's okay. And they do a drilling, and then they are building parts. What they do is that they convert something like this one, a metal, into something that is useful. Something that is useful. It can be a part of a car. It can be parts of any machine. Things like this. All right. Okay. Let's go to another lab. Thank you. Chemical engineering lab. Right? I think here is it okay? Yeah, we can go in, right? Yeah. Okay, excellent. Maybe for safety, just stand over here. And only when we enter here, we need to wear proper PPE, the protective PPE, personal protective equipment, all right, PPE. And sometimes when they do experiments, they actually need to put this up to protect their eyes, right? Just like this. That's why she's wearing. So yeah, so this is where they do a lot of. Mostly, this one is a chemical.
These are all analytic equipment.
So okay, so they analyze the component of the chemical inside here. I mean, if you watch CSI, if you watch CSI, crime scene investigation, they always send their sample to the lab to do chemical analysis. So it looks something like this one. No, I think maybe we for this one we can go upstairs.
Okay.
Yeah. Okay. So come. So next, we will go to a more environmental science type of engineering, where they chemically induce the, what they call that, the gas. So you can see the students actually doing experiments. For safety, for just for this level. So what they do is that they're actually generating the carbon dioxide, right? So the gas, carbon dioxide gas, artificially generating the carbon dioxide gas through here. The students actually learning how to do this. Okay, cool. Maybe just here, right? This is for safety. There's one thing about it, UNNC, right? Safety is paramount. If you want to know the quality of the university, look at the safety, how strict they are in the safety procedure. Okay. Come next. It's open, right? You need to close. Okay. If you are our star graduate, things like this, just come here and watch the. You got the card? You can go in. Yeah. Now, what you see here is this is called the Civil Engineering Structural Lab. All right. Now, let me show you a little bit. Hello. Maybe just come in here a little bit. So you can see all this impressive machine. What you can see here is that maybe we can just come here a little bit. This one is a little bit safer. Come here. Yeah. So if you can see here, what they do is that they do a stress test on the concrete, and then you have the steel bar and how the mixture of the concrete and the steel bar, and then they do a stress test, and then they investigate where the cracks are from. So they can only do with this huge machine, and it's very impressive. And there was one time I was here where they cracked the whole thing is so loud, right? This is interesting. So this one is what they do is a concrete compress machine, is it? Yeah. This is to test the concrete, how the mixture of the concrete, how good it is. You see, they just to do a compress test. They have another one stress machine to stress to look at this one. This one is to see the bending of the concrete. After you do a bar, right? So how much it actually bends. Okay, come, let's go. Next lab. Now, okay. So what we do is that we will go the next level, right? The next level. Should I close the door? Yeah. For safety, the door needs to close. So what we do is we go to the next level of this building. Hopefully the line is still okay. Just be careful. Normally we take lift, but this is equally okay. It's actually a fire escape. Sorry? Yeah, on this side first. Okay. So go to a geotechnics lab. This is also a civil engineering lab. Just now, if you remember, just now we go to a structural lab, right? So we are at the higher level, so we can see the same one from here. I'm sure that you can recognize the machine, the one that we are talking about just now. Now, this one is a geotechnics lab where they actually do the investigation on the soil, right? So one thing about in civil engineering, the composition of the soil, the type of the soil is very important. So they do a lot of this kind of experiments to look at the composition of the soil and how they actually affect. If you want to build something, right? You need to have you have the deep knowledge on the soil. But this is remember just now I mentioned about the student who artificially generate the carbon dioxide. So this is from the upper view. You can see the students are working. All right. Okay, excellent. Shall we go out from here? This side also can. Okay. This building is so big also. I've been here for already almost close to 6 years. I still learning my way around. Okay, excellent. Let's go to this part. So we will be going to the what we call a model workshop, right? Or a modeling workshop. So most of this workshop is used by the product design and development students, and the architecture students, where they have models. They want to build a prototype, and they actually build it in this lab. Hello. Okay. Yeah. No student here. I think probably it's towards the end of the semester already. So something like this, they have like these blocks, these are polystyrene, and they can actually, carve it out. They can carve it out, put it here. And some of the projects, some of the things that they do is really good. Right? For instance, like this one. Well, this one is a 3D printed. So they actually, they do all this. So they design in the computer using computer-aided design software. And then they actually transfer their ideas into here. You want to have a look? Okay. Oh, this is a 3D printer. That's a 3D printer, right?
Yes.
Yeah, that's a 3D printer. Yeah. So some of the things that they do, what you see here is not. It looks like a wood or concrete, but actually it's a polystyrene. Right? It's actually polystyrene. That's how they carve it. They carve it out from here. Okay, excellent. Next lab. Now, the next lab is something that I learned by heart, right? That's something that I learned by heart. that's my lab, electrical and electronic engineering. Okay, let's see. I think got students inside. They're still doing their experiments. Not really. This is interesting. Okay, good. Let's see if the professors are inside there. Okay, what you can see. Shun, how are you? So, what the students here, they are doing a project, what we call a project design. A project design subject where what they do is that they not only learn things in the class, they actually come to the lab and then build something out. The way how we arrange it is that you got the first 2 weeks, you go to the classroom, and like normal people what they do. And then the third week, the whole week itself, they will go into the lab and build something out. They build something out. And then the fourth week and the fifth week, they go to the class. And then the sixth week, they come back to the lab again. The whole week itself is just full of projects. So I think this one, where is Shun? Shun. Shun. Where's Dr. Pai? Dr. Pai Shun. Shun. Come. Good. Probably you can see he's one of my colleague, professor. So Shun, what do you think they're doing here?
So currently they are building a digital board which is used to communicate with another sensing board, and this is used to make a Doppler radar to measure the speed of a moving object.
Just like the police try to measure your speed if you go speeding, right?
We will give you a ticket if you are over the speed.
Okay, thank you, Sun. So they are building a Doppler radar, right? The Doppler radar. They're building a radar. These are just let me recognize. These are just a year 2 student. They are just year 2 student. Yeah. Okay. Year 2 student. So anyway, let's go to another lab, more interesting one. Okay, equally interesting. Equally interesting. I think let's go on the right side. Is Kate here? Yeah. So on the right side, this is what we call a chemistry lab, right? This is a chemistry lab. This is where they do a lot of experiments using chemicals. Now, there's a lot of rules and regulation in this lab. This lab is one of the tightest safety rules and regulation because of safety, you know. One of the first thing is that you cannot use a handphone in this lab because the students are supposed to focus and concentrate on the things the chemical that they're handling, and to make sure that they don't have the concentration lapse when they use handphone, things like this. This is just one good thing. Another thing is that the students all are trained in safety. Let's say if there's an accident, if there's a chemical spill on their face or their eyes, the first thing that they are trained to come here is just to pull here, so that they can actually shower here to actually make sure that to clean all the chemicals. And then what they do, if their eyes have chemicals, they can come here and then they can shower their eyes using this one. I was told that this one, they test this equipment every month, right? Yeah, every month. The other thing is that like this one also is like a safety also, you know, right? One thing is that we don't want the chemical to actually sprinkle, you know, to your eyes. And the other thing is that this one is for fumes. If some chemicals, they have a lot of fumes, the byproduct of the fumes. So what happens is they will suck it out immediately over here. No student experiment today. But the other thing is that if there is an activity going on, we have to wear this, just in case. Now, this one is what we call a thermal fluid lab. If you know about this word called hydraulic, so hydraulic is the force that actually moves something using a fluid, right? So hydraulics is one thing. The other thing is that some of the things that to simulate how the air condition is working and how it is built over here. Because of COVID-19 also, nowadays we actually have things like this one. It's like a webcam. So our students actually can quote-unquote do their experiments overseas. There are a lot of ways that we can do it. It depends on the professors, but one of the most common term that we do is that because the students overseas, they don't have like a certain equipment like the lab or the chemical. So what they do is that they will give instructions to our technicians over here to how do you have to mix and then record. What they do is that they collect the record and then they will do analysis. All right. So, you know, even in the middle of pandemic also that we actually think of the students who are currently stuck overseas. Okay, next lab. Let me see. So all this is safety first product. This one is a project lab, right?
This is research lab.
It is a research lab. Okay, we can't go in. It's a research lab. You know, there's the difference between a research lab and a teaching lab because research lab is more top secret. It's more top secret. You cannot simply just show your research to the people. Here no more, right? Yeah. Maybe. Yeah. This is a part of a mechanical engineering lab, but why I like this lab so much because of the view. I really like this lab so much because of the view. Because if I do experiment, I can enjoy the view, and it's low risk. It's not really high risk lab, so I can enjoy the view of the Trent building, the iconic tower, clock tower of the University of Nottingham. Okay. Excellent. Come on. We can go up already. Can close the door. We can go up. So the next one that we will be going is the level 3. Level 3 don't have much lab. Mostly are the offices of the professors. Let's just go up here. So we go up again. Let's go to the studio. Yeah. Okay, what you're looking here is these are all the offices of all the academics, the professor. My office is on the 4th floor, not here. That's interesting. Okay. So we go to this studio. This is the this one. You think can go in? Oh, this is a little bit messy now, but yeah, if a workstation is too clean, that means that you don't do work. This one is a product design studio where the students actually make smaller models and then they actually do drawings, right? They do drawings of the design. I can see few of the drawings are here. These all are hand drawn, see? These are all hand drawn. So the professors actually teach them how to actually draw and how to actually color it, right? Just like kindergarten, but then it's just it's a very, very fun things to do because you can do drawings if you want. This one is not because they always do exercise over here. It's because now what they do is that one of the project is to how to improve the design for this treadmill. That's what they told me. Design it involves not only about usefulness and functionality, they also involve in aesthetical point, where how beautiful it is, how attractive it is, right? This one is architecture. Workshop studio, you can call it. But if you can look at here, the past projects. So the students actually built. This one I can recognize this. This one is a church, one of the church in Lawaitan, in Ningbo. Yeah. So students actually do their design here. See, like this, mostly this architecture design. I think this one is a past projects. Yeah, this one is a past projects. Sometimes they use the 3D machine to do this. Okay. Next one is the one. So next one is we go to another lab. There is another electrical and electronic engineering lab. Okay, great. So far, no question?
No question, but you can ask.
You have any questions? That's very weird. My student always ask questions. This is interesting. This is all the PhD students' office. PhD students already got their own office. They do their, they can sit in not to relax, but actually do their work. And sometimes once in a while, I visit my PhD student here. This one is a microcontroller and microprocessor lab or embedded system lab, mainly for electrical electronic engineering students. Probably come here. This is one of the, currently the students, they're doing some of the projects. What they do is that if you look at your phone or things like this, they have a chip inside there. So the chip is, what they do is that they write codes and program the chip, and at the same time they transfer it into the circuit board in order to make it functional. Today's world is different. We don't use too much of hardcore electronics anymore, so we use a lot of codings in order to define the chip itself, to define its function. Okay. Next. Yeah. Excellent. Okay. This lab also is this lab also is something that I spent a lot of time previously. Let me see. Okay. Oh, it's still messy. A little bit messy. At present, mechatronics students actually use this lab, but what they do is we going to this lab is for the electrical electronics students to do their final year projects. Final year project is, at the end of the electrical and electronic engineering course, you will need to do individual projects. It's not only electrical, electronic, but mechanical engineering, civil engineering, the chemical engineering. They also need to do some sort of a final year individual project. So,
there is one question.
yes.
How many students per lab class usually have, please?
Normally, like just now, you see what Professor Dr. Bai, his lab. That one normally we got about 70 students. Yeah, because that's earlier. Yeah, but towards to the final year, a lot of students, they take a lot elective subjects already. So usually the class about 20 to 30 class. So this lab itself, the capacity for this lab is about 25. So if it is not enough, then we will schedule it differently. But this lab, what we plan to do is that we want to do the lab as like open lab, means because it's a project lab. Open lab means that people come in and out as they like, just to do the project. Whenever they have time, they just do the project. So we provide a lot of amenities, things like this. You have literally so many screws and transistor resistors, things like this. So what the students just come here, they have their project, and suddenly they need the hexagonal socket of this size. So they can just pick it up here, and then they can just use it. Or they want to do soldering, or even they want to do some sort of a remote control. So we have the remote control and the servo for the students to do their projects. So we have a lot of like robotic projects. If you look on top here, can probably come here a little bit. Like project like this one, it's a spider-like. This is one of my students' project. It's a spider-like. It's a spider-like project. This is what we call hexapod. It's not powered, but then if you put it like this, it walks like a spider, right? It walks like a spider. So it walks like a spider, and this what they actually use nothing more than just Arduino just to program. Of course, Arduino is not powerful enough. But then it's what they do is just use it as to proof of concept. This one is interesting. That one is a drone, right? So the student actually built the drone, flying drone. It's not really 100% built by the students, because what we do is that we purchase the parts, and this one is that the students write the codes to actually make sure the drone is fly and then it's stable, all this kind of thing. So all the things that you learn in the class will be used, the knowledge will be used to do all these projects.
Just one question. So
Yes.
is this lab open for students to use all the time?
That's the intention. It's used for the project students who are doing final year projects to do their work. It's a bit messy now because there's so many students. I think the students go to the class to do this.
So these are their personal projects, right?
Yeah, mostly they are their personal projects.
Patrick wants to see if there is a computer science lab.
Computer science lab, we can go to level 4, the artificial intelligence lab. Computer science, one thing is that it's computers, so but I tell you, how much power they have in that computer is crazy. So that's why we go to this the AI lab, artificial intelligence lab. This is one of the example of the computer labs. Hang on a second. So we are at the top floor of the building. My office is quite far away, but I intend just to show you. I don't know whether it's okay. Good. So this is one example of the computer science lab. Students are doing projects on artificial intelligence. Mainly they use a HPC, a high-powered computer, to this huge or they use Ubuntu to write the codes. All right. Of course, if certain labs, computer labs, we have the what they call the Macintosh lab, the Mac lab, where we have a lot of iMac inside the pizza, but it's in another building. And then we have a lot of computer labs. If it is your computer science students, they have a specific lab for them. We have even a common lab for all. You know, nowadays, even you are in mathematical science, if you are in chemical engineering, your electrical, electronic, mechanical, everything you use computers. All right? Everything is what you call computers.
Another question.
Yes.
Is it hard to get in computer science program?
As of now, challenging because the space is that much, but the number of application is more than the space that we have. So, and also you are competing with the students from China, and students from China also they are competing on the space. But for you, I think it's international students. You don't compete directly with the in terms of student numbers from China, but they have a certain space, limited space for them to come in. So, hello. So, certain limited space that translate what we call supply and demand. Hello, Dr. Zhang. This is one of our professors.
Hello.
Yeah. Okay.
And
Sure.
another question, is
Yes.
it possible to transfer from another engineering program to CS?
Yes, it's possible, but then it's not easy.
Not easy.
Yeah, it's not easy. You in UNSC, like I mentioned, computer science, right, is one of the most highly demand, course. So already that space is this much, and how you want to transfer it, unless there's somebody in the computer science transfer out. So that is the challenge that you might have.
How many students do we have for computer science in total?
I think easily they call about hundreds, one class, hundreds, 120 plus, 130 plus, and then one class. The second and third most popular program like mathematical science and electrical electronic engineering. That one, usually we are talking about one class about electrical electronic engineering about 90 over students. But in one single class, mathematical science, I think definitely got more. I think about 120, 150 plus students.
How about the international student rate?
Yeah. International student rate, normally, on average, we are talking about 12%, 12 to 15%, depending on the courses. Some courses, like mathematical science, right, it's super popular among the Chinese student, because for some reason, I think probably you already know, the Chinese people, they really like mathematics so much. So, but then that is the, that's the competition that you're looking at. Shall we go to aerospace?
Yeah.
Yeah, we can go to aerospace. We can go all the way down here. Yeah. 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 A bit more detail. Okay, so we are in the yes.
Computer science still.
Yeah, yeah.
Accreditation.
Yes, accreditation. We are accredited by the BCS, British Computer Society. So yes, it's accredited by the. I think we have it here. I think we did mention. Yes, there we go. So computer science, we have two programs. One is computer science, and one is Bachelor of Science in Computer Science with Artificial Intelligence. So it's accredited by the BCS, British Computer Society, for the Chartered Institute for IT. All right. Any more questions? Okay, great. So let's go to another building. Science and engineering, we have two buildings actually, two main buildings and one small building. But the next building is where we should go. Hopefully the line is okay. We'll see how. Today is a little bit gloomy. because I don't know, the weather is a bit weird, today, gloomy and foggy, right? What do you see? Careful with the car. There's a vehicle. Yeah, and marine, marine. E is what? Marine economy technology. All right. So it was created for that particular purpose. But then officially the name is very mouthful, long. Yeah. So what we're going to do here is that the first thing we're going to visit is a more open research lab. All right, a more open research lab. For normally they actually built the huge motor for the drone. Okay. Hello. And there we go. The line is still okay? Yeah. Actually, this building, I don't say all, but most of the labs here are actually research labs. So this one I mentioned, I said that these are the key laboratory for more electric aircraft technology of Zhejiang province. We are related to this company, Comac, right? Who actually built the Chinese their own passenger airliner. Actually, what they do is that they are looking into the electric engine. Just careful a little bit. Well, these are their research team, huh? Okay, so I just want to show to you some things. Do you know what is the use of this cage? Okay, maybe I just talk a little bit about this. This is a motor, all right? This is a motor that they built for the drone. I'm not talking about drone that the people use to play, all right? This is the huge real drone that can carry people, all right? They can carry people. So they build very high efficient motors in order to fly the whole thing up easily. They also built the rail track, the engine for the what they call that, for the train. So the electric trains, high-speed electric trains, they also actually built that. So you can see that those are the turbines. These are not gas powered. These are not gasoline powered. These are all electric powered. These are all electric power motors.
So is this place open to all students to visit?
Unfortunately, this is a research lab. The best way, if you want to visit here, is to make an appointment with one of the researchers here, and they make sure that things are not dangerous before you come here to visit. If you look at here, the cage, this is what we usually call the cage. The cage is here for a reason, where they test the propeller, the motor, right? The propeller. They need to close it so that if anything wrong, the propeller fly, it will not hit people and injure people. There's another part. This one is for the advanced and smart, intelligent manufacturing. Some of these machines were built by our professors, and some of these, like this one, what they do is that they did some experiment. They modify this machine so it become more efficient, and it's a lot more cheaper to manufacture parts, things like this. Like this one also. This one is for the laser cutting. I cannot open this one because I was told that I was told by Haonan, don't simply open this one. But this one is for they do cutting the lasers, and what they do, I've seen before, they cut it very fast. Within seconds, you can get a whole prototype of a parts of a machine that you can actually screw it and assemble it for your machine. Okay, so the next one that we'll go is to the aerospace studio, right? The name is studio, but actually when you see it, it's going to be very interesting. If you see it suddenly, you want to become a pilot. But aerospace is not actually the study of becoming a pilot. Aerospace is the study of you building an aircraft. That is the whole point about aerospace engineering.
So for the researchers, is this place open for 24 hours?
Research lab always open 24 hours because the researchers will actually need to, sometimes when you do research, you need to go on for momentum. However, I think risky experiments they will normally do during the work hours. Hopefully the line is okay. We are in the lift.
It's okay. The
Yeah.
internet, I'm not sure. It's going on.
Still going on? Okay, excellent. Because we're in a lift, right? We are now online. Okay, come.
And still some
Come.
people asking about
Yeah.
are there any classes offered, lab classes offered for year 1 students?
UN students, of course, they're offered to everybody. Yeah.
So from year 1 students start to take some laboratory classes?
Yes, yes. Year 1 student in our lingo, year 1 student is like a foundation.
Yeah.
Now a foundation year. So yes, if you take physics class, you take chemistry class, you need to go to the labs. Okay. Now this is what we call flight simulator lab. Flight simulator. If you can see here, can actually fly an aircraft here. I can become a pilot, a captain, right? So I can fly, and then you have a co-pilot, and just flying with the screen here. The best part is that the one who teach you how to fly is actually a real airline captain, a retired airline captain from the Singapore International Airline SIA, Professor Devinder Yadav. So he actually retired as a captain in the airline industry, and he go into the academy, and slowly he rose to become a professor in what we call the aviation management. So he actually teach the student how to fly. Now, a lot of people ask me, why do the aerospace students learn how to fly the aircraft where they are not really trained to be pilot? Now, think of it this way. How do you want to design the best vehicle, best car, if you don't know how to drive the car, right? So that is the question I tell the student. If you know the limits of flying or this kind of thing, then probably you will know how to design the best aircraft possible. So it's very interesting. Students, they love it. They actually had a lot of fun. And at the end of the day, they can land the aircraft, Cessna. The name of the aircraft is Cessna. I think they also do the planning, the flight path planning, how they do this. Okay, do we have any more lab down there? One more, right, down there? Okay, good, excellent. So let's go to the final lab, the last lab that we can visit. Like I mentioned, a lot of research lab they tell us better don't come and record it because top secret. Yes, top secret. Something like there's a joke, say that I can tell you the secret, but after that I have to kill you, Okay. This building in the future will be fully managed by the Faculty of Science and Engineering. We have 4 floors for this building, but at present we only occupy for labs 2 floors, and then the 3rd floor is offices by the professors. We're waiting somebody in the 4th floor to move so we can put more labs over there. You still can continue? Now it's okay? We usually call it as the additive manufacturing machine. So you can see here, can see over here, inside here. Can you connect?
Yeah. BCS, what does it mean? Patrick is asking.
BCS stands for British Computer Society.
Yes. So what's good if the students will do this major with such kind of accreditation?
No, actually, the thing is that I ask you, right? I ask you, if you are a doctor, you just graduate from a university, a doctor, and would you, if you are the patient, would you want a doctor to treat you if that doctor is not the course that they study is not accredited or is not what they call that is not quote unquote check, right? Check or scrutinized by a professional body that is solely representing all the professionals of the doctors. Yeah, that's my point. So the British Computer Society, they are the practitioner of the computer science people. And if they come and accredit our course, that means that, and then they said, okay, we approve your course is accredited and it will be listed in our website. And in the future, when you, when you graduate, then after a few years of working experience, then you can register professionally as the Chartered Institute of IT practitioner. So in this case, it's just like a doctor, right? Or the lawyer. Lawyer, you have to go to a bar council or things like this to register professionally. For me, as engineer, I registered as the professional engineer, as a chartered engineer with the Engineering Council of UK because my course that I have studied previously was accredited by IET, Institute of Engineering and Technology. So this accreditation body is actually the real professional practice people who actually devote their time in order to safeguard the profession itself, the quality of the profession itself. Right?
Yeah.
Any questions or you want to know more about here? Okay, this one is, I think if I'm not mistaken, it's just more of a testing. I think probably after they build something, right? They build the thing, the 3D. Actually, this one is, it can be a plastic, it can be also like a form of a metal. So after they build all this, right? After they build all this, they need to test it, probably over here. They have a test rig. It looks so interesting. And it's very hard. The test rig. We got another one, right? No more? Okay. Oh, okay.
There are some students asking about our rankings.
Sorry?
There are some students asking about our rankings.
Ranking, okay, very interesting. For University of Nottingham itself, the ranking is 98, the whole world. So we are top 100. For this campus alone in China, we are number 68. Number 68, you think that is, wow, 68 is so far away, right? It's just within China. But I tell you, China has thousands, literally thousands of universities. We are the top cream in China. Number 68, we are much better with a lot of what we call Project 211 universities. Project 211 and Project 985 university is what we call something like a quote-unquote the yardstick for the people in China to measure the quality of the university because of the support from the government who actually funding their research and what they call that, their facilities itself.
So what about the Faculty of Science and Engineering, the majors especially?
We are actually proud to say that a lot of our courses, right, are actually what we call key discipline courses in the provincial and national as well as the municipal level. Now, the key discipline, they're looking not only about the quality of the research, but they're also looking at that quality of the discipline in terms of teaching and the quality of the academics. How well they perform. There are many indicators that they look at. It's not only how well they teach, also how deep is their knowledge in their area of expertise. Like me, my area of expertise is this one, mobile phone. So my research is mainly on 5G. Very hot topic, but actually it's not really all green topic. It's a very difficult topic full of mathematics. Yeah.
gown with my own name on it?
It's not really a strange question, you know. Actually, if you graduate PhD, yeah, please go, the colleague. So if you graduate with PhD, you are given the option to buy the gown. You are given the option to buy the gown. But then if you are not graduate as a PhD, we don't really give you a new gown, but it's an old gown. But you can ask if you want to buy. So like I say, you know, study until PhD, then you can get your own gown. They can follow you everywhere, including the hat. There's a very special hat on that.
I think that's all.
That's all.
Yeah.
Okay, so excellent. Happy to see you all, and I hope that you can consider to come to our university to basically study our academic courses. As you can see that I actually bring you around. There are many more other buildings that I want to show to you, but I was told that please limit, don't talk too much, because you know there's you know, virtually if I really want to take you for a tour on this one, I think the whole day won't be enough. There's simply too many things. But what we can do is that I will encourage you to go to our website, particularly for the Faculty of Science and Engineering website. There is a link for you to go to look into each of the lab in our faculty, literally over 70, 80 labs that we have.